Several areas in Romania, such as Dobrogea, the Romanian Plain, or the Fagaraș and Brașov hollows, have soils with low selenium content. Because of its importance, a deficiency in selenium would result in cardiovascular and malignant diseases. Dr. Florin Oancea and the top researchers of the STIM 4+ project aim to develop an improved farming system for field-grown vegetables. The nano-selenium plant biostimulant will enhance the vegetable's tolerance to stress and determine an efficient and safe supplementation of edible yield with selenium. Keep watching Research in the Spotlight to learn how plant biostimulant can compensate for the drawbacks of the high-residue cultivation system and improve people's health globally. Dr. Oancea, thank you for having us today.
Thank you very much for being with us here.
How are you?
Thank you very much.
Currently, you are implementing a collaborative research project funded under the Norway Grants. How did the idea of this project come about?
We noted that in Romania, the field-grown vegetables are less and less. And in order to increase the interest of the farmer for this kind of the profitable crop and with socio-economic importance, we want to implement an method of cultivation related to the use of cover crops, winter cover crops, as source of mulch. But because raw materials, the plant residues from the mulch, are generated also some drawbacks, we look to methods and to means to counteract these drawbacks, to compensate the drawbacks of this system of cultivating vegetable into the high residue systems, into the mulch resulted from winter cover crops. And we arrived to the idea of the new type of plant biostimulant, microbial, organic, and inorganic. Microbial meaning trichoderma, various strains of trichoderma, which are responding to the strigolactone, which are a new emerging, recently discovered, in 21st century discovered plant hormone, and nano-selenium, and microalgae extract. Why nano-selenium? Because Romanian Plain and Dobrogea are area with selenium deficit into the soil. Dobrogea with high deficit into the soil, and because of the common geological history, have the same selenium deficit like the Scandinavian peninsula. Yeah, and it's clear was quite difficult, but the idea of using nano-selenium was interested for the both countries, Romania and Norway. It's clear that in Norway it will be not possible, even with the Gulf Stream and with the climatic change, to make field-grown tomato. Yeah, but anyhow, we could find a common point on the nano-selenium and on the plant biostimulant. Plant biostimulant being a new category of the product, recently defined as being different from fertilizers and plant protection product, and are the products which are increasing the plant tolerance to the stress, especially to the abiotic stress, meaning drought, heat, frozen, heavy rains, flooding, pollution, yeah, exactly, heavy metals. This kind of the abiotic stress, plant biostimulant increase tolerance of plant to the stress. In the meantime, enhance and benefit the nutrients which it's taking by plant from soil, and also it's improving the edible yield quality. For that reason, this was another goal of our project. We would like to have once again the taste of the old tomato.
Are there any partial results that you would like to talk about?
Since we started the project for almost 2 years, we already developed the plant biostimulant, new nano formulation of this kind of the plant biostimulant, and we make for the first year we make the field experiment with tomato grown onto mulch, resulted for winter cover crop, and we treated the mulch with this kind of the biostimulant in order to compensate the drawbacks. And we have already interesting results, which were also promoted. We could obtain these results because the conditions, the meteo condition was very favorable. Was a highly water deficit, which led to a severe drought condition, and high temperature, which allow us to underline the benefits of our agrotechnical system. In the normal condition, probably the results will be not so obvious. But right now, comparing to the control, we have clear, better results. Better plant development, better yield, increase quality of the fruit. And also it's a modification of the soil, which is leading to a new equilibrium, which is more favorable to the plant resilience to the climatic stress.
Which is the main social impact of your project?
The main social impact of the project is related to the quality of the vegetables which are grown in this kind of the system. Are vegetables which have high content of nutrients, including micronutrients such as selenium, which are have a high content of carotene, and should be more affordable because the crop have a higher yield.
And your kind of experiment, let's say, or soil treatment, could be adapted also on other soils in Europe, or it's just for Romania?
No. Could be adapted in other soil to Europe, where, for example, this kind of the vegetable grows in winter cover crop mulch was used especially in the Mediterranean area. But once again, our system, the difference of our system is that we are using plant biostimulant, this kind of the new generation plant biostimulant, in order to compensate the drawbacks. Because when in Turkey or in Italy, it's a long history of cultivating vegetables in the field. Turkey, for example, is a third or fourth country, and they cultivate it, but anyhow they could benefit from our results for sure.
We are discussing a collaborative project involving a team of researchers with various backgrounds and an international partnership with a prestigious institute in Norway. What does it mean to you and the team you coordinate such a partnership with, and what are the benefits?
The project, I will discuss first of all about the transdisciplinary approach of the project, because it's a transdisciplinary approach. It's involving not only the nanoformulation or synthesis of strigolactone or preparation of the bio-based plant biostimulant. It's related also to the plant physiology, to the plant pathology. It's related to various methods of investigation. For example, colleagues from Petroponi Institute of Macromolecular Chemistry are developing right now NMR for the for the tomato and for other vegetables in order to make metabolomics and to understand the basics, the background of better taste and better quality, are the two small enterprises, one which is organizing the field experiment and the other one which has expertise and is making the synthesis of the strigolactone mimics. And of course, the most very important are also the Norway partners. The Norway partners are dealing mainly with the ecotoxicology of this new plant biostimulant, and especially of the nano-selenium and of the strigolactone. Strigolactone are, as I told you, are totally new, and because they are very complicated, we make synthetic compound which are mimic of the strigolactone. And we need to know that these are not only good for the plant, but also are without toxicity towards others component of the environment. And they tested, our partner tested the toxicity for the water organisms which are the most sensitive to the pollutant. Besides that, we are developing with the Genotech, the Norwegian SME partner into the project, we are developing new methods to select plant biostimulant related to the comet assay, and because it's a patent in we're intending to patenting this method, I will stop here with presenting here.
And in the end, what should people remember about your project?
I would like for the people to think that this project intend to bring them the vegetables from the grandma time, the same vegetable that the grandma is using to make our breakfast or the salad for our dinner. This is because field-grown vegetables with great taste and with high nutritional value.
Thank you for watching Research in the Spotlight, a podcast for scientists and passionate science people made under the Norway Grants research program by the Executive Agency for Higher Education, Research, Development and Innovation Funding as program operator. Until the next time, like and share this episode if you think science is a key to a better future.